Hey everyone, today we're going to go over acids. So acid nomenclature, both naming it from the formula and from the, or writing the formula from the name. So let's go ahead and begin. One thing I do want to say is that we've already went over how to do these. So if you need to do that, go back to the explanation of how to do uh, acid nomenclature along with the rules that are in the packet. So the first thing we have to do is go ahead and look at some of these that are over here. And this one right here does not begin with hydrogen, so it is not an acid, it's actually a base. Bases end with hydroxide. So I'm not going to do that one. We're going to go ahead and do this one right here, number two. And number two says I'm going to look at the anion. So we're always going to look at the anion, again, which is the negative ion. So if I pull this up, I'm looking for SO3. It's polyatomic. So if I find SO3, and I know that SO3 is in that third column, there it is. SO3 is sulfite. And if you remember, sulfite changes to ic. So they're saying adic, itis. Ite goes to us. So this is going to be sulfite. So it's going to be sulfurous. Sulfurous. Oops, let me just go back. Us, acid. And again, it's that simple. We're just looking at this. We go to the second one. Now that's sulfur. We know it's sulfide. It does not contain oxygen. So that means we need to put hydro at the beginning. And then ide goes to ic. So it's hydro sulfuric acid. Now remember that if it does not have oxygen, put hydro at the beginning. If it has oxygen, we just go ahead and know whether it's 8 or ite, and they're all going to have that. Let's go to the next one. We have PO4. So PO4 is, if we scroll up here, is phosphate, and 8 goes to ic. So this one is going to be phosphoric acid. We go to the next one. This right here is a type 3, and it's a base. This is one that I told you always need to know. We're not going to worry about this one because that's a base, but you should know what it is, and you should figure out what it is. Okay. Hint, ammonia. Okay, let's go to the next one. Here we have HCN. There's no oxygen, so again, we're going to put hydro at the beginning, and now we're going to look for CN. CN is, again, a polyatomic ion. We'll go back to the first column, go down to CN. There is CN, it's cyanide. Ide goes to, like 8 goes to ic. So it's going to be hydrocyanic acid. Okay, let's go to the next one. That's the base. Okay. Again, it's a type 1 polyatomic ion, so we just name it calcium hydroxide. Okay, iron hydroxide, but it's going to be iron 3 hydroxide. So let's go to this one right here. We know there's no water, there's no oxygen in it, so we're going to put hydro at the beginning. P is phosphorus, or the ion phosphide. So ide goes to ic, so this is going to be hydro phosphoric acid. Okay, let's look at some of the names in front of these here. And so we're going to write down the formula from the name. So we look at this first. Right? Hydro means no oxygen. So I know that it's going to begin with an H. So now I just go no oxygen. So it's not going to be fluorate or fluorite. It's just going to be fluoride. So fluoride, okay, is just going to be a here, fluoride. This charge is a -1 because it's in column 7A. So that means I only need one hydrogen, and then we just need to put the F. Okay. hydroselenic acid. Again, we're going to begin with H, but selenic, it has hydro, so there's no oxygen, so it goes to I, selenide. Let's go back to our periodic table, and we see that it's right here. That means it's in 6A, which means it's a type or a charge of 2. So it's a -2. So that means I have to have 2 hydrogens. And then I put the symbol for selenide, which is Se. And we can double check that and look at it. Yep. Selenide, selenium, Se. Carbonic acid. We know that it begins with a H. We don't know how many it is, but there's no hydro, so that means it has oxygen. So it goes back to 8, so carbonate. So let's find carbonate. Carbonate is right here. It is a -2. So that that means that we have to have 2 hydrogens. So if I go back here, I know that I'm going to have 2 hydrogens. And then carbonate was CO3. And we're just going to put in CO3. Again, that's simple on how we do that. Let's go to lithium hydroxide, a base, nitrous acid. Nitrous, so we have an H. And nitrous, us means excuse me, nitrite. Okay, so nitrite, go back to our polyatomic ions. Here is nitrite, NO2. It's a -1, so I only need 1, and then we put NO2. So go back here, we need 1, and then we'll put NO, subgroup 2, nitrous acid. Cobalt 2 hydroxide, that's a base. Okay, and it's basically going to be CO parentheses OH parentheses 2. Let's go down to sulfuric acid. There's no hydro, so that means it's sulfate. It goes to 8, so it's going to be H. So let's go ahead and find sulfate. Sulfate's in the 3rd column. Okay, so sulfate is right here. It is a -2, so that means I'm going to put 2 hydrogens and then SO4. So back here, I'm going to do a subscript of 2 and then SO4. Notice that we never have any of the polyatomic ions in parentheses. That's because hydrogen's 1. Hydrogen is a +1, and so hydrogen is the only one that we have to change. Okay, let's do hydrobromic acid. Hydro means no oxygen, so that means bromic goes to bromide, and here's bromine goes to bromide. So that's in column 7A, which means there's 1. It's a -1, so it needs 1 valence electron. That's going to share, or that's going to take. And so let's go ahead and go back to that. And so we're just going to put Br. So I only needed 1 hydrogen, 1 bromine, hydrobromic acid. And as always, remember that all of these are in an aqueous solution. Okay, all of these ones that are here are in an aqueous solution. Hey, hopefully it helped you out. As always, go Mohawks. Nelson out.